Welcome to qnawire.
Hi. In this problem, you are given a 5 picofarad capacitor. So let's draw it like this. So you have a parallel plate capacitor. The plates are circular plates. The capacitance is 5 picofarad. So 5 picofarad, that means 5 times 10 raised to negative 12 farad capacitor. And so it is connected to an electric circuit which can have so let us make an electric circuit, a simple electric circuit. So the electric circuit can have the maximum potential. So Vmax, the maximum potential supplied by the circuit is going to be 100 volts. So we are going to have the maximum potential difference across two plates of the capacitor is going to be 100 volts. And the maximum electric field between the two plates of this capacitor can be Emax can be 10 raised to 4. 10 raised to 4 Newton per Coulomb. So this is the maximum potential and this is the maximum electric field across the two plates of the given capacitor. Now, in the question, it's been asked that assume yourself to be an electrical engineer who is being assigned a work on live wire electronics, and your task is to design a capacitor for the given conditions, Vmax and Emax. So you need to find the physical dimensions and the separation which you must have between the plates of the capacitor. So with the given condition, you are required to find, you are required to design the capacitor. So let's go ahead with this. Uh, so before jumping into the problem, let us identify what we know about capacitors and parallel plate capacitors in general. Uh, so for capacitors, the capacitance is given by cap charge Q over the potential difference V. So C equals Q by V. So this we very well know. And for parallel plate capacitors, the capacitance C is given by epsilon naught A over D, the separation between the plates. And there is yet another information which we know and which we will need to use here, that the relation between the potential and the electric field. So the potential difference between the two plates of the capacitor or between any two ends is given by V equals E, the electric field between the two ends, times the D, the separation. So this is like, so if you have any two, so if you want to measure the potential difference between these 2 points A and B, so the potential difference between the 2 points A and B can be measured using this. So V equals E, the electric field between the points A and B, and the distance between the 2 points A and B. So that is how we measure. So let us jump to the first part of the problem where it is assumed that you are an electrical engineer and you need to design the capacitor as per the given condition. So let us write the given condition once again. So we have Vmax equals 100 volts and the Emax equals 10 raised to 4 Newton per coulomb, which is the units for electric field. So this is the given condition to us, and as per these conditions, we are required to find the dimension of our capacitor. So since we know that the potential V equals the electric field E times D, so for the given conditions, we can find the separation between the plates of the capacitor. Maximum separation between the plates can be D equals, so let's write V max over E max, which is going to be, so you have 100 divided by 10 raised to 4, so which is 10,000, which comes out to be 0.01 meters, or in other words, it is 1 centimeter. So good, we found the maximum separation between the two plates can be D equals 1 centimeter. So this is the maximum separation between the two plates. So if you have to design the capacitor, the separation between the two plates of the capacitor should not exceed 1 centimeter. So 1 centimeter is a good separation for the plates. Then in the part B, let's try to find, so once we have found the separation D, we need to find the dimension of the capacitor. So it's the plates are circular plates, so we just need to find the radius of the plates. So since for parallel plate capacitors, the capacitance C equals epsilon naught A over D. So from this, we can find the area of the capacitor, which is going to be your capacitance times the distance divided by epsilon naught is going to be equal to, so the capacitance is given to be 5 microfarad. So 5 times, oh sorry, it's given to be 5 picofarad. So it's 5 times 10 raised to negative 12. So that is the given capacitance of the parallel plate capacitor times the distance which we have just found. So make sure that you write the distance in meters, because the capacitance is given in farad, and we are using Anki as units here. So the distance was 1 centimeter, or 10 raised to negative 2 meters, divided by the epsilon naught, the standard value of the electric permeability, which is 8.85 times 10 raised to negative 12. So if you solve this, you will find that the area of the plates of each plate should be equal to 5 point, sorry. So the area of each plate is going to be 5.65 times 10 raised to negative 3 meters square. So this is the area of each plate. And since it's given that the plates are circular, So we can write that the area of each plate is going to be equal to pi r square. So I'm going to equate this value which we have found here to the pi r square. So let's do that. So the area which we just found, which is 5 times 6, 5 times 10 raised to negative 3 equals pi r square. So from this, I can very conveniently find the radius r to be square root of 5.65 times 10 raised to, sorry, it was negative 3 divided by pi. So let's say it's 3.14, and approximately this value comes up to be 4.24 times 10 raised to negative 2 meters. Or in other words, the radius is going to be r equals 4.24 centimeters. So this is the dimension of each plate in terms of radius, and that is the distance between the plates. So we have found the distance between the plates and the dimension of each plate using the given conditions. And now we are required to find the charge, maximum charge that each plate can have. So the maximum charge Q is going to be C times V. So we know the capacitance of each plate, which is 5 times 10 raised to negative 12 farad, and the maximum voltage, which is 10 raised to 2 volts. So let's not write the volts here, only the values. And the maximum charge, the capacitor that two plates can have is going to be 5 times 10 raised to negative 10 coulomb, or in other words, it's going to be 500 picocoulomb. So we have found charge on each plate, which is going to be 500 picocoulomb. So we have found the distance between the two plates of the parallel plate capacitor, the dimension in terms of the radius of each plate since they are circular plates, and the charge on each plate. Thank you.